Certainly. Here's the text with proper punctuation. In a noteworthy declaration that could change our situation in the universe, NASA has detailed the discovery of the first extraterrestrial signs coming from the course of Proxima B, the nearest known exoplanet to Earth, found simply 4 light-years away in the habitable zone of its star, Proxima Centauri. This revelation has created an influx of fervor and interest overall. Could this be the moment when mankind finds that it isn't the only one in the universe? The way to this pivotal disclosure started with careful observation by NASA's powerful telescopes, which have been observing distant stars and planets for indications of life. Proxima B has always been a main candidate in the quest for extraterrestrial insight due to its Earth-like attributes and its proximity to our own planetary system. The signal distinguished is specific and unlike anything cosmologists have ever seen prior, denoting a potential defining moment in mankind's history. The ramifications of such a revelation are significant. First, it affirms the well-established scientific speculation that life could exist on other planets under Earth-like circumstances. Second, and perhaps even more fascinating, it raises the question of the nature of the civilizations that could exist there. Would they be simple microorganisms or advanced beings possibly capable of interstellar communication and travel? This signal from Proxima B isn't just random noise or a natural cosmic anomaly. It conveys an organized repetition that suggests an intelligent origin. NASA researchers, alongside international teams, are now tasked with deciphering this message, trying to understand its content and the intentions behind it. The global academic community is abuzz with hypotheses and theories about the possible substance of this message. A greeting, a hello, a warning, or something entirely unforeseen. News of this discovery has transcended the bounds of established researchers, sparking discussions via social media, in government rooms, and around dinner tables. People are gazing toward the stars with renewed wonder, considering creatures who may be doing the same on a distant world. How similar or different could their reality be to our own? What might their society be like in terms of technology and culture? These possibilities seem as vast as the universe itself. Additionally, this discovery opens up various moral and existential questions. How might mankind respond if the signal, indeed, comes from intelligent beings attempting to communicate? What protocol should we establish for interstellar diplomacy? And, most importantly, how might such a revelation change our understanding of religion, life, and our very way of being as individuals? While excitement is growing, there is also considerable skepticism. Researchers at NASA and other space agencies are working diligently to verify these findings, ensuring that the signal is not a false positive or a distortion. We are on the very edge of what could be the most significant discovery in human history, so the next steps must be taken with precision and responsibility. The world waits eagerly for further detailed examination. The discovery of extraterrestrial signals from Proxima B not only moves our scientific endeavors into a new era, but also connects us with a profound sense of curiosity and hope. We could finally be on the brink of answering one of the most profound and significant questions. Are we alone in the universe? In April 2019, a radio transmission was detected coming from space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it might seem like a vast distance, it is the nearest star to the Sun, being 500 times farther away than the third brightest star in our sky. The signal comes from a triple star system made up of the binary pair Alpha Centauri A and B and Alpha Centauri C, otherwise known as Proxima Centauri. Alpha Centauri A and B, the two stellar companions, are relatively close to each other and quite similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times more luminous than the Sun, while Alpha Centauri B is half as bright with an orange tint. Alpha Centauri A is somewhat larger than our Sun, and Alpha Centauri B is slightly smaller, so our Sun fits precisely between them in size. However, where did the signal between these two stars come from? The notable breakthrough, the Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named the Signal Breakthrough Listen Candidate 1, BLC-1. The project, with roughly $100 million in funding, has utilized years of observation with cutting-edge telescopes worldwide. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope was monitoring the region of Proxima Centauri, the nearest star to our Sun. This signal nearly slipped through the cracks among the vast volumes of data collected over years, but the researchers managed to identify it like a needle in a haystack. For the signal to be considered relevant, it must have two distinct characteristics. First, it must be confined to a narrow frequency range, as such radio transmissions are not produced by natural cosmic phenomena. Second, the frequency should fluctuate according to the general movement of the exoplanet concerning Earth. The researchers had to analyze nearly 4 million individual signals captured by the telescope in Australia. After a thorough process of filtering and eliminating irrelevant signals, they identified 5,000 distinct signals, among which one stood out, a signal that could not be explained later when cross-checked with contemporary radio transmitters on Earth. This exceptional signal, with a narrowband technological signature, only appeared when the telescope was pointed towards Proxima Centauri and was observed over a 30-hour period. After examination, it was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method, which detects variations in a star's position caused by the gravitational pull of orbiting planets. The star depicts a small circle, and highly sensitive spectrographs are used by scientists to track the light from a star. The spectrum of light shifts slightly towards blue as it moves away from us. When these movements occur repeatedly in regular patterns over days, months, or years, it is accepted that now's what more we will be able to achieve in the future. Wouldn't it be astonishing to find a planet capable of supporting life? One of the primary objectives of the James Webb Space Telescope during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the possibility that they can contain water and organic life. Webb's research on star and planet formation allows us to connect studies of mature exoplanets to their birth conditions, as well as link our own solar system to their origins. Webb's infrared capabilities are excellent for revealing how stars and planets form for three specific reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and reveals the presence of key chemical components like water and organic compounds. Mid-infrared light can pass through clouds that are 1,000 times denser than visible light, which is particularly important when observing infant stars concealed within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to form young stars. However, there is more to the natal clouds of stars than that. Both young stars and giant planets begin as massive, expanded structures that gradually contract over time. As young stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible frequencies. This means that the Webb telescope will be ideal for finding new stars and planets and helping to understand the physics of their formation. With its MIRI, mid-infrared instrument capability, Webb will also search for hot molecular gas near various young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, much of the James Webb Space Telescope's early science work will focus on determining how planetary systems form, including the particles that may be crucial to the development of life. The search for extraterrestrial life has long captivated the imagination of mankind, fueling scientific inquiry and speculative fiction alike. The recent detection of signals from Proxima B represents a significant milestone in this mission, potentially heralding the discovery of life beyond Earth. As researchers continue to explore and decode these signals, the implications for our understanding of the universe and our place within it are profound. Proxima B orbits Proxima Centauri, a red dwarf star located a little over 4 light-years from Earth in the constellation Centaurus. Despite its relative closeness in cosmic terms, reaching Proxima B with current technology remains a formidable challenge. The journey would require spacecraft capable of traveling at a significant fraction of the speed of light, pushing the limits of our engineering capabilities. The signals detected from Proxima B display characteristics that distinguish them from ordinary cosmic phenomena. Their organized repetition and narrowband technological signature suggest an intelligent origin, raising intriguing questions about the nature of the civilization responsible for these signals. Are they similar to humanity, with aspirations for exploration and communication across the universe? Or do they represent a form of life and intelligence vastly different from anything we have encountered before? The discovery of extraterrestrial intelligence, if confirmed, would have far-reaching implications for our understanding of science, evolution, and the conditions necessary for life to thrive. It could provide insights into the diversity of life forms that may exist beyond Earth, and offer new perspectives on the potential for life in extreme environments. Moreover, it would challenge fundamental assumptions about the uniqueness of human intelligence and the role of consciousness in the universe. In addition to its scientific significance, the detection of signals from Proxima B has sparked widespread public interest and discussion. Conversations range from the practical implications of interstellar communication protocols to philosophical reflections on humanity's place in the universe. The possibility of contact with an extraterrestrial civilization evokes both excitement and caution, prompting reflections on our responsibilities as stewards of Earth and custodians of humanity. Ethical considerations surrounding the discovery of extraterrestrial life extend beyond scientific inquiry to encompass broader cultural and societal implications. How would the discovery of intelligent extraterrestrial life affect religious beliefs and philosophical perspectives? Would it unite humanity in a shared sense of wonder and curiosity, or would it provoke fear and uncertainty about the unknown? The search for life beyond Earth is not limited to radio signals from distant exoplanets. Advances in astrobiology and planetary science have expanded our understanding of potential environments for life within our own solar system. Moons like Europa and Enceladus, with their subsurface oceans of liquid water, offer tantalizing possibilities for microbial life adapted to extreme conditions. Future missions to these icy worlds, equipped with advanced instrumentation capable of detecting biosignatures, could provide definitive evidence of extraterrestrial life closer to home. The James Webb Space Telescope represents a significant leap forward in our ability to study exoplanets and search for signs of life beyond our solar system. Scheduled for launch in 2022, JWST will utilize its advanced infrared capabilities to peer deeper into the universe than ever before, revealing new insights into the formation of planets and the conditions necessary for life. By studying the atmospheres of exoplanets, JWST will analyze their chemical compositions and search for biomarkers that could indicate the presence of life beyond Earth. Beyond its scientific objectives, JWST embodies humanity's enduring quest for knowledge and exploration. It represents a collaborative effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, united in a shared commitment to unraveling the mysteries of the universe. The telescope's remarkable sensitivity and resolution promise to transform our understanding of planetary systems and the potential for habitable conditions beyond Earth. In parallel with cosmic observations, advancements in artificial intelligence, AI, and machine learning are revolutionizing our approach to analyzing complex datasets from telescopes and spacecraft. AI algorithms can sift through vast amounts of data more efficiently than human researchers, identifying patterns and anomalies that may signal the presence of extraterrestrial intelligence. By combining AI-driven data analysis with human expertise, researchers are accelerating the pace of discovery in astrobiology and expanding the frontiers of knowledge. The discovery of extraterrestrial life, whether microbial or intelligent, would have profound implications for humanity's future, identity, and direction. It could inspire new generations of scientists, engineers, and explorers to pursue careers in space exploration and astrobiology, fostering innovation and technological advancement on a global scale. Additionally, it would prompt us to reevaluate our position.